Hello, 171 class. This is an example from your 1.6 homework. This is problem number 20. We got this function that models the median height in inches of children who are X months of age. Okay, so I'll blow it up here just so you can see it. So as their age gets larger as they age, their height is growing, but it's kind of like not growing as fast. It's kind of growing faster at the beginning than it is towards the end. Alright, so the first question wants us to describe how the graph can be attained using transformations of just plain old square root. Okay, so this, remember, this is a vertical stretch. It's a number bigger than 1, so it's going to stretch the graph vertically. So we know it's going to be B or D, stretch vertically. Okay, there's the only ones that stretch vertically. But then the plus 28, that's out of the parentheses, meaning it's out of the square root, so it's happening after. So that's going to shift upwards. So it's going to stretch vertically, and it's going to shift upwards, right? So it's not B, it's D. Alright, and then the second thing it says, according to the model, what's the median height of children who are 36 months of age, 3 years old? Alright, use a calculator. Alright, so all we're being asked to do there is just to replace this X underneath the square root symbol with 36. So 1.5 times the square root of 36 plus 28.6, which is the same thing as just 6 under there. So I get a 37.6, and they tell us to round to the nearest tenth, so 37.6 inches. Alright, the actual median height for children at 36 months is 38 inches. Okay, how well does the model describe the actual height? Alright, 38, 37.6, that's pretty good. Alright, use the model to find the average rate of change in inches per month between birth and 12 months. Alright, so if we use 0 for X, that's birth, and then if we use 12 for X, that's month. So the average rate of change can be found using the average rate of change formula. Okay, so this is the average rate of change formula. F of x2, f of x1, those are y values. Those are outputs of some function. And then x2 minus x1, those are inputs of some function. So we're going to go back to the original and pull that in here. So there's our model. We're using g of x here, but it's same concept as using f of x. So we're going to pull this in and come up with our average rate of change for this. Alright, so let's modify this, because, I mean, it's the same concept, like I said, but let's just make sure we're on the same page. F of x, g of x, h of x, w of x, whatever, they all mean the same thing. So we can apply this to be g's, since the function itself I gave you was g's. Alright, so x1, it said birth, 12 months, so x1 is 0. x2 is 12 months. So that means we're going to plug in 0 into this thing, and we're going to plug in 12 in. Okay, when I plug in 0, I get 1.5 times the square root of 0, which is 0, plus 28.6. That's just 28.6. When I plug in 12, I need to go to the calculator. Okay, so 1.5 times the square root of 12 plus 28.6. What I'm going to plug in the calculator. This is the last thing I did for the last problem. If you hit second enter, it'll bring back the last thing you did, and since we're using the same formula, I'm just going to change the 36 to a 12. So I get that number, 33.8 roughly. Alright, so that's about 33.8. Okay, so g of x2, that's g of 12, okay, 33.8 minus g of x1, it's g of 0, that's 28.6, divided by x2 minus x1 is 12 minus 0, which is just 0, or which is just 12. But we plug that in and we see what we get. So 33 minus 28 is 5.2 divided by 12. 5.2 divided by 12. Alright, and it tells us to round to the nearest tenth. we got 0.433333. So rounding that to the nearest tenth would just be 0.4. Alright, find the average rate of change between 50 and 62. So we're right back to this guy, but this time instead of 0 and 12, we got 50 and 62. Alright, so using the same concept, I'm going to plug in 50 here, 62 here to get those two outputs. But I'm going to plug them into the calculator to get them, okay? Alright, I'm going to change this to a 50. Alright, what I'm going to do here is I'm going to use the store button. I'm going to say store alpha A, and now the letter A is that number. Okay, and then I'm going to bring back our formula, change the 50 to a 62. Alright, and then I'm going to store that as B. Okay, so there's B. And then I'm just going to plug into the formula. So this number is G of 50, this number is G of 62. If I do parentheses B minus A, there's the numerator of this formula. Alright, divided by the denominator is 62 minus 50, so it's 12 again, just like it was last time. So there's our average rate of change this time, 0.1. Alright, so how does this compare with your answer to part C? It's smaller. Alright, so A says it's smaller, C says it's smaller, so it's one of those two. So is it steep or is it not as steep? It's not as steep the further we go. So that's C.